Hello everyone. In this video, we are going to discuss about Argand plane and polar representation from the chapter 4 Complex Numbers and Quadratic Equations class 11 Max. See, Argand plane, it is actually the complex plane or the Z plane. Z is actually the complex number. So, Argand plane, it is actually a complex plane or the Z plane. Z is the complex number. Okay, now here you see, I have just marked 4 axes here, x, x dash, y and y dash. See, the x axis in the Argand plane, that is actually called as the real axis. And the y axis in the Argand plane, that is actually called as the imaginary axis. Now, in the complex number, z is equal to x plus iy or a plus ib, anything you can take. So, here I am taking the complex number z is equal to x plus iy. In this complex number, x is the real part and y is the imaginary part. Now, the location of this complex number z is equal to x plus iy. It is represented by the ordered pair x comma y. Okay, so this point P, which actually represents this complex number z is equal to x plus by iy, which is by this ordered pair x comma y. Okay, so this is how we represent a complex number in the Argand plane. Now you see here the complex number z is equal to x plus iy. Now the modulus of z, which we have already discussed in our previous video, this will be equal to square root of x square plus y square. Okay, that is when we have discussed about the complex number z is equal to a plus ib, the modulus of z was actually square root of a square plus b square. So here z is equal to x plus iy. So modulus of z is equal to square root of x square plus y square. And you see, this is actually the distance between this point P of xy and the origin O. Okay, origin its coordinates will be 0, 0. So this distance from O to P, this is actually the modulus of Z, which is equal to square root of x square plus y square. Okay, now you see the points on the x-axis corresponds to the complex numbers of the form a plus I 0, because real axis has the real numbers. A is the real part of the complex number. Now, if we consider the complex number a plus ib as a is the real part. Okay, similarly, see it has only the real part a, so x is called the real axis. Now, the points on the y-axis that corresponds to the complex numbers of the form 0 plus ib. Because you see, for this complex number 0 plus ib, it has only the imaginary part. Okay, that is why this y-axis called as imaginary axis. Now, the complex number z is equal to x plus iy that corresponds to the ordered pair x comma y is represented geometrically by this point P. Now, the conjugate of this complex number z, conjugate is z bar, that will be equal to what? X minus iy. See, we have already discussed about the modulus as well as the conjugate of a complex number in our previous video, which is available in the playlist. So, you see the conjugate of a complex number z bar, that is equal to x minus iy. Okay, this actually corresponds to the ordered pair x comma minus y. It is represented geometrically by this point Q, which is x comma minus y. Okay, so you see geometrically this point Q, which is x comma minus y, that is the mirror image of this point P, which is of the coordinate x comma y on the real axis. Okay, now you see the plane having a complex number assigned to each of its point, that is actually called as the complex plane or the Argand plane. The plane having a complex number assigned to each of its point, that is called as the complex plane or the Argand plane. Now, let us consider a complex number 2 plus 4i. Okay, this actually corresponds to the ordered pair 2, 4. So it is represented geometrically by, you see, 2 units on the x-axis and 4 units on the y-axis. 2 units on the x-axis and 4 units on the y-axis. So the point will be, 2, 4, no? So the point will be somewhere. So I am representing that point as A. Okay, so this A is actually 2, 4. That is the complex number 2 plus 4i that corresponds to the ordered pair 2, 4. It is represented geometrically by this point A. Okay, now I am taking another point, another complex number 0 plus 1i. So you see this complex number 0 plus 1i, or before that let us take another complex number minus 2 plus 3i. I'm sorry, I'm taking this complex number first, minus 2 plus 3i. Okay, see this complex number minus 2 plus 3i that corresponds to the ordered pair minus 2 comma 3. It is represented geometrically. How? You see, here we have minus 2 on the x-axis. Okay, 3 on the y-axis. So, minus 2, 3. So, it will be somewhere here. So, this point is minus 2, 3 and I am naming this point as B. Okay, so this complex number is geometrically represented by this point B. Okay, now let us consider the next point, which is, I am taking the next complex number as 0 plus 1i. So this complex number that corresponds to the ordered pair 0, 1. Okay, so 0, 1 means 0 on the real axis, 1 unit on the y-axis. Okay, so 0 on the x-axis, 1 unit on the y-axis, so this point. Okay, so this point is corresponding to 0, 1 and I am naming this point as C. So this complex number is geometrically represented by this point C. Okay, now let us consider another complex number which is 2 plus 0i. Okay, so this complex number is corresponding to the ordered pair 2, 0. 2 unit on the x-axis, 0 unit on the y-axis, that means this point itself. This corresponds to 2, 0 ordered pair. I am naming this point as D. Okay, so this complex number 2 plus 0i is geometrically represented by this point D. Now, let us consider the next complex number which is minus 5 minus 2i. Okay, see this is represented by the letter C and this is corresponding to this point D. Now I am taking this point which is minus 5 minus 2i. Okay, so minus 5 minus 2i, this complex number is corresponding to the ordered pair minus 5 minus 2. So minus 5 units on the x-axis, minus 2 units on the y-axis. So the point will be somewhere here. This point is corresponding to the ordered pair minus 5 minus 2. I am naming this point as E. So this complex number minus 5 minus 2i, it is represented geometrically by this point E. Okay, now let us consider the next complex number which is 1 minus 2i. This corresponds to the ordered pair 1 comma minus 2. Okay, so 1 unit on the x-axis, minus 2 unit on the y-axis. So 1 minus 2, the point will be somewhere here. This point is corresponding to the ordered pair 1 minus 2. I am naming this point as F. That means this complex number 1 minus 2i, which is corresponding to the ordered pair 1 comma minus 2 is represented geometrically by this point F. So I hope it is clear to you. In this video, we have discussed about the Argand plane and the polar representation. The rest of the videos are available in the playlist. Thank you.